All right, this video is for the second part of the test over Unit 2, and we're going to start right away with number 15. Again, it's two parts. It's a compound inequality with an and. So I'm going to solve the first part by adding 5 to both sides of the equation. Negative 5 plus 5 will cancel out, and we'll have 2/3 x is less than 1 plus 5 is 6. But then we have to undo multiplying by 2/3. So we undo multiplying by 2/3 by multiplying by its reciprocal, which is 3/2. The 3's will cancel, the 2's will cancel, and we'll have x is less than, we can multiply 6 times 3 is 18, divided by 2, which is 9. And then we have a second part to this. Right now, negative x is less than negative 3, but that's like negative 1x. So we could divide everything by negative 1. So we have x. The sign will switch, and negative 3 divided by negative 1 is positive 3. So x is greater than 3. So on a number line, here's 3. It would be an open circle at 3 and going to the right. And then at 9, it's another open circle, and it's less than 9, so we're going to move to the left. And we should have something that looks like that for number 15. If we move to number 16, again, compound inequality, two different parts. This time it's separated with an or, so we don't have to satisfy both conditions, just one or the other. And I'm going to solve the first equation by adding 3 to both sides. So 5n is less than or equal to negative 5. And then if we divide both sides by 5, then n is less than or equal to negative 1. Second part of this is I'm going to start by getting rid of the 4. We can subtract 4 from both sides. So negative n over 3 is less than negative 2. And a lot of people did this, they multiplied. We're dividing by 3, so they multiplied both sides by 3, and that's a good way to do it. The 3's will cancel. We'll have negative n still is less than negative 6. So if negative n is less than negative 6, I can divide both sides by negative 1. And n is greater than, the sign switches, positive 6. So we have two parts to this. Here is negative 1. It's a closed circle at negative 1, and it's less than that, which means we're moving to the left. Or n is greater than 6. So at 6, we have an open circle, and we want the values that are greater than that, so it would move to the right. Let's take a look at number 17 then. Number 17, your class hopes to collect at least 500 cans of food. Well, at least 500 cans of food is going to be something like this. Whatever you collect, they want it to be greater than or equal to 500 cans. For the annual food drive, there are 122 cans donated the first week. So we already have 122 cans. Plus the second week, they donated 144 more cans. And they want us to let C represent the amount of cans donated the third week. So we're going to have another week. We're going to add whatever is donated the third week, so that when we add all of these together, we want it to be greater than or equal to 500. And that's the equation you should have for part A. Then to solve that equation, if we add 122 plus 244, that's 266 plus C is greater than or equal to 500. And then we can get C by itself. If we subtract 266 from both sides, the amount of cans that need to be donated the third week is going to be 500 minus 266, which is greater than or equal to 234 cans. And remember, it says how much does it cost, or how many cans do you need to meet or surpass your goal. So we can't just say 234. That's how much it is to meet our goal. But then we need that or more. C is greater than or equal to 234 to surpass our goal. Let's take a look at the last page of the test then, starting with number 18. A homecoming committee at your school has decided to sell homecoming t-shirts. The setup fee and layout for the shirt is $38, and you make a profit of 75 cents on every shirt. So we can start this like this. You make 75 cents for each shirt. I'm going to let X represent the number of shirts. but you have to pay a cost of $38. So you want to sell a lot of shirts so that you make some profit. It says that you want to make a profit of at least $100. That's the equation you should have. To solve this equation for part B, we would add 38 to both sides. So 0.75 is greater than or equal to 138, 0.75x. And then if we divide by 0.75 from both sides, x is greater than or equal to whatever 138 divided by 0.75 is. So 138 divided by 0.75, which is 184 shirts that you'd have to sell. Number 19. Write a compound inequality that would describe the maximum speed of 70 miles per hour. So that means if L is the speed limit, you have to go less than or equal to 70. But a minimum speed, that means you can go 35, but you have to go more than 35. It would look something like this. The graph would be from 35 to 70. You could go 70, you could go 35, you could go anything in between. And the graph would look something like that. Now, number 20 is a little bit different, however, because it says kids that are 6 years old or less. That means if your age, I'm going to call it X, is less than or equal to 6, you can eat at the salad bar for free. But then senior citizens who are 66 years or older, your age can be greater than or equal to 66. This must be an or here. You cannot write it like this because it would mean that you would have to be less than 6 and you would have to be greater than 66, which is impossible. So we would graph this like this. You could be 6 or less, or you could be 66 or more to get the free salad bar. So be sure to turn in your corrections when you finish. Make sure that you are writing down what it is that you missed on each problem in order to receive the full credit. You want to write down your mistakes.